ladies and gentlemen.
The last major type of triangle we're going to talk about is right triangles. So right triangles, one of the angles is fixed to 90 degrees, and the other two, because they have to fight over being 180 degrees total, must be complementary, or summing to 90 degrees together, because the other angle is 90. All right triangles have a special property where the square of the largest side, which we will call the hypotenuse, is equal to the sum of the squares of the shorter two sides, which we would call legs. Something else that happens, and these names are important, the hypotenuse is the side across from 90. Since 90 has to be the largest angle that this triangle has, the side across from it would be the largest side. So that's going to be our hypotenuse. The legs of the triangle are the ones that actually touch the 90 degrees, and they have to be the shortest two sides. So that's known as Pythagorean theorem, or some other theorems. He's not the guy who made it, he's just the guy who's credited for it. We have a squared plus b squared equals c squared. So if we take the two small sides, a and b, square them and add them together, it's equal to the largest side, c squared. Let's try it out. So if we have two small sides of 8 and 6, what is the largest side of x, which is the hypotenuse? So we can set up 6 squared plus 8 squared is equal to x squared. Well, 6 times 6 is 36. 8 times 8 is 64. 36 and 64 make 100. What number times itself is 100? Also known as taking the square root. That would be 10. So x has to be 10. If you're asked to find a leg, instead of adding, you'd end up subtracting. So just keep that in mind. You might have to do a little bit of algebra if you're trying to find the legs of a right triangle. These Pythagorean theorem numbers that work out to be whole numbers, all three of them being whole numbers, are called Pythagorean triples. It's good and useful to memorize, but it's not required. So some common Pythagorean triples we have are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25, and any multiple of these. For example, this triangle worked out, and we had 6, 8, and 10. Well, 6 is 3 times 2, 8 is 4 times 2, and 10 is 5 times 2. So multiplying all of three numbers by 2 still gives us a Pythagorean triple. So let's use that to try to save us on a little bit of math. So if I am given So let's try out another Pythagorean theorem question, but this time one where it's not as straightforward. So if I have the hypotenuse is 15 and one of the legs is 9, what is the other leg? I can do Pythagorean theorem. I can do x squared plus 9 squared is equal to 15 squared, which essentially is just x squared is equal to 15 squared minus 9 squared. 15 squared, that's a big number. Some people might not have that memorized, but that is 225, and we're taking away 9 squared, which is 81, and that is equal to x squared. Well, what would that be? That would actually end up being 144. So x squared is 144. We take the square root of both sides. What times itself is 144? That would be 12. There is a nicer way to do this, though. 15 is 3 times 5, and 9 is 3 times 3. 3 and 5 is part of the Pythagorean triple, making this 3 times 4, and therefore 12. So that's how I can help you out a little bit, but then again, not all of your right triangles are going to be these nice triples, so it's always good to be able to use the Pythagorean theorem as a reliance and as backup. That is it for our right triangles here. We're going to deep dive into some special right triangles in another video, but as far as general right triangles go, this is all you really need to know. If you have any questions, let me know. Otherwise, I look forward to seeing you in the next video.